Are you all hungry already? So, who is? So after this one, we hopefully can get some nice lunch. So, hello everybody. My name is Jonas Nussdorfer, and I'm here to talk to you now about a field report, actually. So this has been in the works since the last year. So my team, we worked on a new embedded project that is based on Zephyr, and we had a goal in mind to have a setup that anybody can work on and don't worry about the setup, don't worry about the installation steps, get everyone who has to change focus and jump back into the project later, get right into the work without having to worry about complicated steps that might occur. And this is going to be just a report of how this whole system evolved in the end. Before we get into the matter though, I want to give you a bit of context. So I work as a software engineer at Leica Geosystems, which is part of Hexagon. Hexagon has committed itself to develop towards an autonomous future. We want to do that by acquiring data from sensors and putting this data eventually to work. And if you take a look at the branches that we cover, so you see we have a variety of devices that we provide to solve different problems. So you see, for example, we have something for the building domain or geospatial. These are usually drones that measure some point clouds, also mining, and machine control. And for me personally, I'm in the survey solutions department. So these are devices that surveyors normally use to measure some points. So if you ever see someone out on the street measuring some points with a stick and an antenna on top, that's the kind of devices we are working on. Some of these devices are not typically embedded, I could say, so there are no restrictions with heap allocations or exceptions, but of course we do have a lot of sub-modules, and these sub-modules are very much embedded, and these are subcomponents of these devices. And like I've mentioned, we have started in our team last year with a new project. This was an embedded project based on Zephyr RTOS, and like I've explained in the first slide, we wanted to have a setup that works for everybody and is easy to use. So what I'm going to talk to you about now, and I'm briefly going to cover this. So first, I want to give you some context of what Zephyr RTOS actually is. So this is just going to be a very brief overview. Quick question, hands up, who has worked with Zephyr so far? Okay, not a lot of people. I know my colleagues do, so they can't chicken out. So I'm just going to briefly show you this. Then I'm going into the meat of the topic. So this is the development setup. Spoiler alert, we are using VS Code and how we're going to do that. And for the last part of the presentation, I'm going to show you a pre-recorded demo of the first time setup, just so you know what steps do you need to do to actually reuse it. And for the end, I hope I can answer some questions and give you a bit of a summary and outlook. So let's actually get started with Zephyr. What is Zephyr? So Zephyr is an embedded RTOS. So this is just based on a very small footprint kernel and was specifically designed to be for resource-constrained and embedded systems. So that's like just taken straightly from the documentation pages. If you want to know more, I will cordially invite you to take a look yourself. And what are some of the most important features of Zephyr? So I've just also taken some interesting points that are relevant, especially for our team from Zephyr. So you have a very highly configurable system that you can use. If you've worked on the Linux kernel before, you know what this is. So this is based on kconfig. Then your hardware is described via device tree settings. So this is all configuration as code. And you have a very nice setup in terms of what is supported. So there's a lot of cross-architecture support for a wide range of supported boards. It's possible to natively develop on Linux, Mac, and Windows. And also quite a nice feature is that there's a native POSIX port. So you can run this Zephyr application as a Linux application. Okay, so this was just roughly what Zephyr is. And for the next step, okay, why did it do that? Yeah. Now we actually need to take a look what is required to set up a workspace when working with Zephyr. And what we did in the very beginning, so we all were very unfamiliar with Zephyr because no one had ever worked with it. And we just started out with installing it locally on our development machines. And if you go to the doc pages, now this is a very rough breakdown of the description on there. But what you have to do is, of course, you will have to install some dependencies, like CMake, Python, and the device tree compiler. Then, of course, install the Zephyr SDK. This is just downloading some file and installing it. And then once you're there, you also have to set up the Zephyr project. So you have to install Vest. This is some meta tool from Zephyr. Fun fact, Zephyr is the name, what derives from the name of the Greek god of the west wind, so this is why it's called West. And then you initialize the project directory with the init and update subcommands, export some CMake package for Zephyr, and of course you have to install some additional dependencies via pip. Quite a mouthful. And at this point we were already, okay, this is getting a bit complicated if you're dropping into this project now. You have to do a lot of installation, sometimes it doesn't work, especially on Windows. We found it a bit of a hassle, and also we found the compile time is a bit problematic. So we were looking for a different approach. And luckily for us, there was already another team in the company who had worked on a setup like this. And what they did, and this is key, because if you look at these steps that you need to do, the first 2 points are actually something that you can put in a Docker container. So I'm not going to go too much into detail what the Docker container is going to do for you. Basically, it's making sure that you have a consistent work environment for everybody. I think you're going to hear a lot more about Docker in another talk, so I'm not going to spoil too much here. And for the third part, you also have to see that these custom steps you somehow have to get under control to make it easy to work with. Okay, so what was the approach that we took? Setting up the development environment. Like I've already said, there was a team that had previously worked on a Zephyr-based project. And we started out with their approach for the beginning. So what they have? They have, of course, their project. Let's call it foo. You have all the folders that you need, so include, source, whatever. This is not very relevant. And they had a sibling repository. So I'm just going to call this foo VS-Code-env. And this VS-Code-env repository has 2 folders that are relevant. So the .dev container and the .vscode. And in there you will find some JSON files. So for the .dev container, you find a dev container JSON. And for the VS Code, a launch, settings, and tasks.json. And what you would do when you work on the project, you clone the VS-Code-env repository, and there everything is set up to actually get your environment the way it should be, and then you will clone the code through that. So this is actually the first approach of the workflow that we took. And now I'm going to go a bit more into detail what these files actually do. So the first thing we want to look at is this development container. And this is where you configure the Docker container to work within VS Code. So and if you take a look at it, you will see that you can, in this dev container.json, do a configuration, what you would basically tell the Docker run command. So you tell it a name, you say which image to run, or you can even reference a Docker file, which you can build on the fly. You give it some mounted folders, you give it some run arguments, maybe even some container environment variables. And of course, you need an extension for that in VS Code. But that's everything you need, and it looks something like this. So you have a pretty simple JSON file with all the configurations that you provide. You can see here I'm building a Docker file or Docker container from file, but you can also do it from an image. So you can use a pre-built image. The only difference is the first time you open it up, it will just take some time to build it, but that's usually not the biggest problem. So if you have something like this in your repository, if you open VS Code, you will see something like this on the bottom left. So if you're on Windows and WSL, it says WSL, but if you're just locally on Windows or on Linux, for example, this will just be the green box with the 2 arrows. And the interesting part is if you click this one, this actually reveals some of the secrets. So it will open up some options to us if you have the dev container extensions installed. And that one says reopen in container because it found the .dev container folder, it sees a dev container.json, and if we hit now the reopen in container option, he will parse this file and do a reload of the whole window, so the whole window will reload, and build Docker container, install all the extensions, and then suddenly we see now this green box and the bottom has changed. So now the VS Code instance, I would say, it's running in the container now. So everything that you do now from this point on is happening inside your Docker container. So this is quite nice. So every extension that you have specified in the dev container JSON, every dependency that is in your Docker container, everything that you need is now inside here, and you can use the IDE without thinking about anything else. So this is already quite nice if you really want to make sure that everyone has the same setup to work with. Okay, let's quickly wrap this dev container setup up. So the nice thing about this is we only have very little requirements. So for the extensions in VS Code, we only need Docker, we need dev containers, and additionally, if you're on Windows, you also need the WSL extension. Other than that, you don't need anything for VS Code. This is really everything you need to make it work. So nothing specific for your development. This is especially nice if you have multiple different projects with different extensions that you need, so you don't pollute your VS Code installation, so to speak. And for Windows, there are a few remarks that you have to remember. So the first thing is that if you're on Windows, it's strongly suggested to use, of course, Docker again with the WSL2. You can use the Docker desktop for Windows, but since the WSL2 version is free, it's much better to use that one. Then, of course, we had quite some struggle with this throughout the beginning because there's always going to be some line conversion happening sometimes between the Windows and the Linux. And also something that we observed is that the code should be hosted in WSL for better performance. So it's better to open your command shell, go into WSL, then do the clone and open the VS Code from there. Because if you do it on the Windows side, he has to transfer all this code back and forth, and it takes a lot longer, actually. So just make sure that it's inside this virtual hard disk or VHDX file if you're working on Windows. Now, for the next steps, I want to talk about the tasks.json. And there, so very surprisingly, this is very similar. So let's recall quickly from the Zephyr introduction. What we need to do is first we need to initialize the project with Vest. Then we need to install some additional dependencies. And maybe you have a more complicated setup to flash your device, which was the case for us, but that's a different story. Or maybe you have some other things you need to do. Maybe you need to install some dependencies via Conan, and you have a specific location you want to install those, or some other steps. So there's actually quite a few things you can do with that. And how this looks like, so it's very similar to the dev container.json. It's a JSON file where you just specify some tasks. So you see, for example, one at the top, this is the init, where you just say, okay, we'll run best init on some folder, and this is just a shell command. Same story for the update. So here you can define custom tasks that you can run to make your life a bit easier. And if you do that, so if you have this task.json ready in your repository, you will see that there are buttons now appearing in this bottom task line. So do you see there's the init and the update is available, and when I click those, then whatever is required to do will be executed there. So this is also quite nice in making this Zephyr installation step a little easier for us, because sometimes it was difficult to remember, okay, what exactly do I need to do now, because I haven't worked with it for 2 months, and then we were getting a bit stuck. So this helped a lot in making things easier here. So this was the tasks.json. Now let's get into an intermediate problem that we faced, and this is about the remote debugging. So if you remember, last year we still had corona measures in place, mostly. So for us, it meant working from home most of the time. And this meant that we needed to somehow be capable to debug the device from home and also turn it off or turn it on again in case something went wrong. And we had an additional problem, that was that we had a limited number of devices ready for testing. So we only had 2 devices, but for a team of 5 developers, so we had to somehow share this in some way. So multiple developers needed to work on the device, and we solved that by connecting all the devices under test to some Raspberry Pi. I'm going to just call those test gates, and for those we had connections via SSH. This one was running the GDB server and also connecting with the JLink. And there we had all the options to control everything. So if you look, so this would be the test gate. There we have the JLink to the device, and the test gate would also take care of the power management. And all the developers that worked on it, of course, they would have to synchronize, but yeah, we could all debug remotely, either from home or from the office. So last but not least, we also have the launch.json, and this is where now the debugging remotely comes into play. And this is, again, very surprising, the same setup as before. So you specify a name, you specify an executable, you specify the devices, maybe some GDB settings. Also, it's possible to add some tasks to execute before launch, and it's all specified in some JSON file. So I'm just pasting an example here. So the details are a bit more complicated, but you can always look it up in documentation. It will depend, of course, on which device setup you're using. In our case, it was a bit more complicated, but this is it's all possible to specify in this JSON file. Okay, so let's do a quick recap of the situation that we have with this state until now. So it's possible to have custom steps be represented by a single task, so making complicated steps easier. It's also possible to group them, so if you want to have some separation there, it's possible to do that. Then everything that is needed to work with the project is inside the Docker container or specified as an extension to install in the dev container JSON. So everything we need to work with is available there. Then with the launch.json, we have the remote debugging. So anything we need to do there is also handled. And the developer, and this is the main selling feature in my opinion, that we only have a very minimal setup that we need. So we really need to have Docker working, we need VS Code, some extensions for it, not even Git actually. So if you have your code fetched from somewhere else, you can do that, but that's all you really need to work with it. So this is quite nice, and at this point you could ask yourself, do we even need more at this point? Because anyone can clone a repo and start working on it right away, and you don't have a complex environment setup. And in theory, that's true. So we can start working on it, and it's all fine and good. But in practice, there's of course a bit more. And the problem is now, what is this a bit more that is holding us back to make it really nice? And for this, we need to take a look at the Zephyr project structure to understand what the problem was. So again, let's take a look at the repository. So we have, as normal, the include and the source folder, and we have some west.yaml file. This west YAML file, this is just a manifest. It tells us which dependencies we need to use and where we need to place them later. Then we would call the west init. So now the project structure changes a little bit. Now we have an additional .west folder. For now, this one is not as relevant, but it will be relevant in the next step. So this one contains a configuration. So it tells us where you will find the west YAML, and then you can continue working from there. So from this step, we now need to retrieve the Zephyr sources and the dependencies. So let's recall, we have the west.yaml and the .west folder, and we call west update on this now. So then the situation changes again. This, of course, depends on what you specified in the west YAML, but by default, it will look something like this. You will get a Zephyr folder, and you will get a modules folder at it. And the Zephyr folder will have the Zephyr sources inside, and the modules will, for example, contain some other dependencies. These are hulls, these are other libraries. Sometimes you can even pull your own third-party libraries and do it via West. So this will usually be located in these modules. And what we observed, and this is where it became a bit painful for us, is that our board was, of course, supported, but not 100%. And unfortunately, this not 100% support was something that we needed. So it was necessary to add some contributions to Zephyr. So that was the first thing that we had. And the other story was that since we were a bit unfamiliar with Zephyr, it was oftentimes the case that you wanted to explore the source code a little bit. And if you look at the project structure that we had before, it was all very deeply nested. So it was very easy to get lost in this deep folder structure, and it's a bit clunky. So how did we solve this actually? And this we solved by refining the setup once more, because there's actually something we can use to make our life a lot easier in that regard. So what we did now, we have still the project. We have the .dev container folder now inside the project itself. So that's a little change. And we now have a foo.code workspace file. And what does this workspace file do? Here we have, of course, again, the settings for tasks, settings, and launch configuration. So these are now absorbed in here. And we have the option to specify which folders we want to work on simultaneously. So this was designed to work on multiple folders simultaneously. And the big change now is, because first we had 2 repositories, now it's just 1. So it's all in there, makes working a little easier because we tended to go out of sync when working with 2 separate repositories. So that was also one important step that we did here. And now okay. Now, how does this multiple repositories and folders setup work with VS Code? The workspace files, like I mentioned, enables working on multiple projects simultaneously, so it treats them as siblings, so to speak, and it will look something like this. So you have first a child node with the folders, so you say, okay, I want these folders as my projects that I'm working on. I've specified the Zephyr folder, then I've also specified modules, NXP, Hull NXP folder, so that's obviously something our chip vendor provided, and the last one is our actual project. So this we have to have last. This is just the dot, and we say that is root. You also see that folders, yeah, I actually said that already, that was a mistake. So yeah, folders that used to be buried deeper now are now siblings, so this is making things a bit easier. This is also nice if you have contributions simultaneously, because the version control tab will also show these as 3 separate entities. So it's easy to keep track on which state you're working on in either project. And lastly, you've also seen this already, the settings, launch, and tasks.json are now absorbed in this file. So these are the same contents, they are just in the same file now. And with that, we have a setup that is very basic, but it works and it's quite nice now. So the next thing is already the demo that I'm going to show you. And as a short disclaimer, so I've recorded this, so I have no chance to change anything now because I wanted to make sure that it works the first time. I didn't consider that dark mode might not have been a good idea. I hope you can see it and I hope you can read it. So I'm going to just play this, and I hope I can keep track with the what I'm showing on the screen, because this is a bit at times fast. And basically what I'm doing, I'm starting from scratch. I'm downloading the repository, I'm opening up code, I'm making sure everything is set up, and I will build everything through. And from that state, we can work. So let's actually, does it do that now? Okay, yeah, so you see now, I will just do a clone from the repository now. So we clone the sample repository, which you will also find later with a link, so I can send this to you. So this should actually be done now. I'm changing into the folder and opening code from there. So now, this was not, where is it? Okay, I don't know what happened here now. It actually skipped some parts. Yeah, no, it's Murphy's Law. What can go wrong will go wrong. Okay, now this is where we actually stop. So I opened code now from this project. You see it's already asking us a lot of things because it recognizes the def container JSON. You see in the bottom left, we're on WSL Ubuntu, so I've done this on a Windows. And it asks us to do the reopening container because it found the def container JSON. So we are going to do that. I'm in the lucky position that I have the container already built, but usually this is where it would pull the image or either built from scratch. And once it is done, it will load all the extensions in, and you should be now in the container. So you see on the bottom left, it says def container, so everything that happens now is happening inside the container. Then there's one more step to do, so it's already done on the screen, but it wasn't fast enough. And this is now we have to open the workspace in order to make the tasks appear and all the settings that we've configured in this JSON file to be active. And with this, everything should be there in a second. Yes. So you see now on the bottom left, we have now the tasks. So we have one for init, we have one for update, also some more for dependencies, and also for some Conan installation. So, and we are going to do that first. So the first thing is West init is being called. So first we have initialized the project. Then the next step would be to do the update. So this will probably take the longest now in the presentation because it's actually cloning all the Zephyr sources, and Zephyr is quite large. But it was done on the company PC, so this shouldn't take too long. In the meantime, you can take a little look on the folder structure on the side. So you see there's the Zephyr folder on the very top. And this one is also the same one that is under root and Zephyr. So these are the same folders, they are only just arranged as siblings. Okay, so Zephyr is close to being downloaded. Yeah, this is always a bit unfortunately. In the meantime, I can also tell you what I did with the CMake presets, because who here is familiar with CMake presets? Anyone? Okay, a few. So what CMake presets basically are, they are just some predefined configurations. You say, okay, I want one configuration to build in release for that toolchain file with these cache variables. And this is just some configuration you can give it. And then you just say, okay, CMake, build me this prefix and preset, and it will do exactly that. Okay, so Zephyr is done now. The next step is to install the dependencies. So this is also some specific step you need to do from the Zephyr installation. Fortunately for me here now, all this is already done. So it's not doing much here. But usually it will download some Python pip packages. And then once this is done, we also need to do the final step, because this is something specific we use a lot. So this is Conan. So we have one additional task specified to do the Conan installation. This is specifically about the Google test library where we have our tests. So Zephyr has a test framework, ZTest. These are run on the device, but we aimed for a native POSIX build for our tests and use gtest instead. So now all the setup steps are done. And now, like I mentioned, I'm building all the presets. So first I'm doing the release. I just selected on the bottom. You can see here the root folder and the presets to build. I've done release already. Debug is following. So this is quite quickly done. And the last one to build is actually the tests. So this is the most interesting one for now. Okay, this is quite fast. And you see you have now all the configurations built that we have available within just a matter of a few clicks actually, and not much to worry. And the tests themselves are also nicely integrated. I think this is what should happen right now. Yes, okay, perfect. So it will take some time, of course, but it will discover all the tests in the test executable. And once it has loaded all of those, this usually takes some time because it's not as nicely as it could be, but you see now all the tests that are compiling are visible, and you can run them individually or run all of them. You can even start the debug and jump to the code location itself. So it's quite nice actually how this integrates. Yeah, and I think that was it. Yeah, okay, perfect. So with that, I'm already getting close to the end of my talk. While I talk to you about like some of the success stories and some outlook, I'm giving you the chance to scan this QR code. This is the GitHub repository of the sample, of the very exact sample that I've just shown you. So you're of course all invited to try it out yourself and play around with it and use it. And in the meantime, I'm going to talk about how this whole setup has held up in the past now. So we've started on this project more than 1 year ago. And by now I can say it's pretty nice actually. So for us in the team, we use it of course, then we have of course the other team that uses it with their Zephyr-based project, and it's, you know, it just works. Then for new colleagues that we had to onboard, they had a much easier time. You know, we just told them, okay, install VS Code, install WSL and Docker, do these 5 steps. This is something you can explain in 5 minutes, and they have everything available. They have built everything, they can debug without much of a hassle. It's all no problem. We also started seeing other teams use this setup, but they worked in entirely different contexts. So wherever a Docker container was somehow involved, they started using this very setup. So we had one team working on some remote protocol, and they had a very different setup with respect to compiler and which operating system and which target, and of course the libraries they were using, but they were using the same pattern. So the dev container file and another Docker container and these tasks. So this was also quite a nice thing. And this is the most recent thing. So we recently ported a legacy project that was a horrible project that was bound to some Eclipse-based IDE. And what we did was we ported this to CMake. You will hear a lot more about CMake in another talk. And we also introduced this pattern that I've just shown you to this project. And the differences immense, because before you needed to install Kinetis Design Studio, which is some Eclipse-based IDE. You needed to install plugins for that, then you needed to update, then you needed to do X, Y, Z. So it was all very complicated. And if you didn't know how it worked, you were basically lost. And the difference now is you just download it. It takes 5 minutes, like I've shown you in the sample, and then you can start debugging it. It's as simple as that. And it's an entirely different platform. It's a different board, it's a different project, and it still works in the same fashion. So this is quite nice. So yeah, I've reached the end of my talk already, so this is quite a trip. We are, of course, always looking for people, so if you want to get in touch and reach out, you can scan the QR code for some hiring, or you can follow us on the various social channels. And of course, I want to thank you for your attention. So how much time do we... Still have 10 minutes? Okay.
Yes, you have 10 minutes.
Before we get to question, because I cut a lot of slides, maybe I want to show you one extra slide, because that's actually where it gets interesting for this whole setup. So we had a very basic setup at that point. But over the course of the last year, we've added a lot of things that, you know, the development was made easier. And I intended this to be like one slide for each with a little explanation, but then I saw that it took too much time, but I'm just quickly going to run down like what we have added. And this is now where you can go to town on this setup. You can add anything you want and everything that makes your life easier. And it's really as simple as add it to the Docker container, or add an extension in the dev container.json file, or maybe both, or you add another task, and that is it, and you can just use it. So I've mentioned it. The first thing was the CMake presets. So these are just some predefined configurations to build, which build type, which cache variables, which toolchain. Then some other tooling that we have used for documentation purposes, just to make sure that graphs are in sync. So we've added ASCII doc and plant UML extensions to VS Code, and also instead the necessary libraries. So you can also draw, when you're working inside this container, some nice graphs. Then another situation we had is we had from our agile tester some automatic system test framework, and those tests are based on C#. And it was possible to integrate this in the setup. So you could install the .NET to the Docker container. Then you needed to install an extension for VS Code. And it was possible to not only execute the system tests when you're working within the VS Code, it was also possible to debug it simultaneously. So it was possible to debug the automation tests and the application simultaneously. And if you had either breakpoint, you would hit on both. It would stop on both sides, and you could take a look like what's going on now. So this is actually has helped us immensely when working together with the tester. So this is nice. And some other tool that we have added was puncover. So this is some tool that allows you to see which part of the code base are expensive to use with respect to size. And that's all integrated in our IDE. You just have some special task, you run it, you see the output, and there's not much you have to know besides which button to click. Now, I know from some of my colleagues I've had quite some criticism. If you're, of course, the command shell wizard that thinks Vim is the best IDE, this is probably not my most favorite tool, but if you're the average developer, you say, or you're new to your team, this is very nice to use. Like I said, you're all invited to use it. Go to town. And now I'm happy to answer some questions if there are any.
Thank you, Jonas, for this interesting talk. We have some time for questions.
Did I get that right, that on the legacy thing that you ported to this, you didn't use Zephyr?
No, that was MQX. If you remember Freescale NXP, that was an older project, yes.
And how much is it tied to VS Code? So if you like Vim, don't want to use VS Code?
I mean, the nice part is you can, for example, do the command shell from within Vim and use it from there. Or what exactly is the question targeting? Maybe misunderstanding it?
Well, I really like that you install all the tools and things like that into the Docker and use it there. And how much is that tied to really using VS Code? You said you need some Docker extension inside VS Code, and do you need that to use VS Code nicely, or do you need that to...
Yeah, okay, now I understand. No, this is needed to make it nicely used within VS Code. So it's, you can of course use it with some other IDE, that's not the thing. So if you just open VS Code and it sees those files and folders, he will say, okay, I found something, do you want me to open this in the container? So it's a bit, I would say it's not very intrusive. If you have it and you open it in VS Code, then it's fine, you can work on it, but of course you can use it just with Vim and the command line, or you have a C-line preference. There's nothing holding you back from doing this. You will just have a different setup. You have to maybe know what you're doing. So because that's the reason why we went for this. We had some of our colleagues already started on the project, some other colleagues were late and dropped in a few weeks later. And they were like, okay, how do I use this? I have no idea. And with this, it was really just a matter of, okay, install that, 5 minutes, you're done.
So just a quick comment, the Vim scripting language is Turing complete, so you can build it all yourself.
So we have two over here. I think you were first.
Just for clarification, the dev container is a feature of VS Code. So those things you would only use and apply if you want to use Visual Studio Code. If you don't want to use it, then you're free to use Docker or whatever pleases you. And dev container is only automating the integration with VS Code. So you can install extension for VS Code. You can prepare your environment as much as you want, and then that's perfect for development setups.
And if I may chime in to this, so of course you can use something else. This was also what we agreed in the team. Like if you don't like VS Code, there's a small anecdote to that. We had 2 camps in the beginning, one camp VS Code because they were familiar with it, and we had camp C-Lion. And the agreement in the team was we have a setup that is commonly understood. Like anyone can use it, and if your special setup doesn't work, you can always fall back to that one. So that was the motivation behind doing this. Yeah, I think in the back there was something.
So I would have 2 questions. Very nice presentation. We've also been using a setup that's maybe similar to what you're doing. So it's, I think we are happy to see that we are not alone. And first question, not totally related, but a little bit. You mentioned that you navigate a little bit before getting to use Zephyr, and I would like to know which was the main motivation to use Zephyr and on your team, and then maybe and then ask the second question afterwards.
Yeah, with Zephyr it was just okay. We have this new generation of software platform, and the other team that I mentioned, they used it and they were experienced with it, and it was just okay. We are also going to use that because we can reuse some of their tools already, or we can take some expertise from them. So that was the main reason why we went for Zephyr in this case.
Because some of the people in your company, in your team were using it, and they were happy with it, suggested that it was a good thing to do, and it shows that.
It seemed to be the way to go for future embedded projects. That's all I can say at this point. I don't know too much about the specifics, why exactly Zephyr was chosen. That I cannot answer that.
And then in our side, we are actually doing the West init, West update as part of the container. And all the Zephyr SDK and everything is coming in, and we're trying to open a back door when if you want to actually change those things. Many times we just work on our application side. So I wonder what do you think about this?
Yeah, we actually thought about this as well, to have Zephyr setup all done in the Docker container, but the problem was part of it is because we were unfamiliar with it, but a lot of the problems drew from having to contribute to Zephyr. And every time we changed something, we would have to rebuild the container again. So that's why we just said, okay, we're gonna leave these as tasks now, because it's anyway, you have to do it for the first time. You only do the init and the update and the installing the dependencies, you do it once, and then on subsequent reopens, it's all there. So that's why we said, okay, this is a half measure between we have to add something and do everything again, but it's a much shorter time span than rebuilding the whole container, just because of that.
Because the reason why we took this approach of taking everything there and trying to have a backdoor to actually inject a different SDK is because sometimes the manifest, you can have tags that are not totally defined. So it could be rolling tags, like it refers to something that can change. And if you do west init, west update, at some point in time, maybe you cannot rebuild with exact the same sources that you were using to build the firmware in the past. If you know, if I
No, not really actually.
okay, so like, well, okay, we'll
Maybe
discuss that.
maybe you talk later.
Yeah, yeah, okay,
That's a
thank
good idea.